One of the greatest threats currently facing humanity is the ever-present, ever-looming rise of antibiotic resistance. If you could all just raise one hand for me, please. Yeah, pop them up. All right. Now, lower your hand again if you have never used an antibiotic. Yeah. As you can see, antibiotics are an essential medicine for the modern age and ubiquitous when it comes to treating bacterial infections. However, this overuse of antibiotics could be leading us towards an apocalyptic post-antibacterial age, a time where a simple infection could lead to long-term hospitalization or even death. Every time a new drug is introduced to the market, the bacteria immediately fights back. And within a few short years to sometimes just a couple months, the bacteria is already showing signs of resistance. The problem therefore is that we're not developing new drugs fast enough in order to combat this rise. Enter the age of the superbug, badass bacteria that refuses to die. The only way that we know how to combat superbugs is with a super drug. But how can our scientists develop new drugs when it can take up to 20 years to develop just one? I believe that a possible solution lies in the development of faster and more efficient chemical reactions in order to build those analogues which can then undergo testing. So that's exactly what my research does. I use nickel catalysts in order to design new molecular reactions to build large libraries of analogues like this one here. So this is a beta-lactam core structure, and it's prevalent within the field of antibiotics because it contains this beta-lactam core, which is highlighted in red. Now, if we modify the rings that are attached to that, we can potentially increase or even sometimes decrease the antibiotic activity of our molecules, and this could lead us towards a structural activity relationship, which could then go on to guide our further studies. So, what does my research boil down to in just 3 minutes? Antibacterial resistance is currently on the rise, and our scientists are not designing new drugs fast enough in order to combat that. What my research does is comes up with new synthetic routes to build these analogues for testing, but also to actually do some of that testing myself in the hopes of discovering a new hit molecule. Welcome to the evolutionary arms race.